Hey, what's up, students? Let's talk about this 7-8 nodes. First of all, we're going to try to spot geometric sequences. Now, to be a geometric sequence, you got to be a list of numbers that have a common ratio. So basically, you're multiplying by the same number over and over again. We used to do these sequences called arithmetic, where you do repetitive addition. Spoiler. You do repetitive addition or repetitive subtraction over. Well, in a geometric sequence, you're doing repetitive multiplication or repetitive division over and over and over again. So what we're going to try to do in these first couple of examples, this is problem number 1 from this page, and this is, the got it question from that page. We're going to see if we even have a geometric sequence. So mental math, friends. How do you go from 20 to 200 to 2,000 and 20,000? I think you take them all times 10. So this would be an example of, yes, this would be a geometric sequence because everything's being multiplied by 10. The common ratio is 10. Again, how do you find the common ratio? If it's not obvious, you take a new value divided by an old value. So if you take 200 divided by 20, you'd get 10. You get the idea. Okay. 2, 4, 6, 8, 10. No, you are not a geometric sequence because you are just repetitive addition. Okay. Now this is kind of a weird one. 5, negative 5, 5, negative 5, and 5. It's not really changing anything drastically. This is kind of one of the weird ones. It is technically a geometric sequence. I'm going to copy and paste this. Okay. Yes, it is a geometric sequence. But what's happening? Oh, they're all being multiplied by a negative 1. So let's go times negative 1. All right. So basically, just flipping and flopping back and forth. Okay. Times negative 1, times negative 1, times negative 1, times whatever. So it's kind of the weird ones right there. Okay. So again, we're looking for repetitive multiplication or repetitive division. So here we go. Let's hunt these out. We go 3, 6, 12, 24, 48. What would happen here, mental math friends? 3 to 6, you doubled. 6 to 12, you doubled. 12 to 24, you double, 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 double. Oh, okay, so everything's just times 2. There you go, that's all you gotta do. So you'd say, yes, this is a geometric sequence because all the numbers are being multiplied by 2. All right, next one. 3, 6, 9, 12, 15. Nope, that's going to be one of these dudes. That's going to be a repeated addition situation. So no, you're just adding 3. That's not what we're talking about. We're talking about repetitive multiplication division. Now, very careful here, friends. Look at the fractions. We have a 1/3, got a 1/9, a 1/27th, and a 1/81st. Okay. Technically, what's going on here? Now the top is all 1. There's not a whole lot you can do there. Okay, it's just 1, 1, 1, 1. What's going on the bottom? Triple, triple, triple. Oh, if I were a person who does math, and I am, I think we have a common ratio, or also known as a common factor, of 1/3. I think that's what's going on here. I think if you take this times 1/3, you get 1/9. You take this times 1/3, you get 1/27. You take this times, oh, that's what's going on. So you just keep multiplying by a 1/3. So this would be a yes, because you're multiplying by 1/3. All right. And some of the other, well, actually, we can finish this off here. We'll do this here in just 1 second. These are the notes that are on the 7-8 handout. But if there were room, I think this is the end of the page right here. But if there were room, if there is room, we would just extend it to the next, because these are the first 4, 5, 6. We would just go ahead and extend it to the next 2 terms. We might do that here in just 1 second. We got space for it. So, all right. Anyway, times 1/3. So yeah, that's what's going on here. So we are multiplying by a third. I want a little x. Give me a little more. Here we go. All right. Last one. 4, 7, 11, 16, 22. All right. Well, that's not times anything. Well, let's see what we get here. New divided by old. 7 divided by 4 equals, oops, is that 1.75 equals 1.75. Okay, so we have that there. So it could be times 1.75. It's not holding anything out yet. It's not ruling anything out yet. Here we go. 11 divided by 7. Ooh, that's like 1.5, blah, 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 blah. Yeah, when you divide by 7, it's not going to be pretty for anybody. So that's about 1.6. Oops, lost my mouse. Oh no, world's melting down. So right away, that's not going to work. That cannot be a right answer. You got to have the exact same common ratio. You can try the next one. 16 divided by 11. No. 22 divided by 16, no. So if there is no common ratio, then you are not a geometric sequence. Sorry, I dropped my mouse. I'm all flustered. It fell underneath my table and I can't reach it. So I'll deal with it. Okay. No, it's repeated addition. It's repeated something. Okay. Some type of pattern going on here. We just can't say it. So we add 3, then we add 4, then we add 5, then we add 6. Okay, so it's some kind of neat pattern, but it's definitely not repetitive multiplication. So, anywho, this video is going on long enough. I think you get the idea. Maybe in class we'll add on the next 2 terms, but once you figure out the geometric sequence, then you can find the next 2 terms by just continuing the geometric sequence. All right, cool. That is the 7-8 notes introduction, problem 1, and the got it questions.